Okay, so this is the design of the triangular shape project. Uh, this is the look, outer shell, and this is of aluminum. This is the glass, tempered glass over here, and yeah, now let's get to the features of it. We have speaker holes. These are the microphone holes, Type C charging port. Uh, if we see inside this, we have the PCB here. We have enough space for the battery as well, and then yeah, this is the separator for PCB and the top cover. The whole assembly is snap fit mechanism, as you can see here. There's a pit and a bump that slides in each other and make it a snap fit assembly on all three faces, like that. So yes, this is the design. This is the update on tissue dispenser. The design has been completed. First of all, let's talk about the outside of this. We have the PIR sensor. Then we have the slit through which the tissue will come out, and these zigzag pattern, that's for cutting the tissue paper, aiding to cut in the tissue paper. These holes are for the snap fit mechanism, for this to lock. You see, just like that, we have hooks here that will fit into lock, that will lock into these holes, like that. And then when we have to unlock it, press into it, it will release and just open it up. Coming back towards inside of this dispenser, we have this tissue roll, which is powered by this motor, the main motor of this box. The motor is attached to a coupling, which is attached to the core support of this tissue. And here we have the gear train mechanism, transferring motion to these rollers, which aid in pushing the tissue paper forward into this slit. Okay, then we have this disinfectant liquid tank. Yeah, add your liquid through this hole using a funnel into this, and then the atomizers, these three atomizers, will make mist and will disinfect the tissue paper that you're going to use. Push this back once refilled, and that's how this dispenser works. Okay, so these rollers are portable, they can be removed as well. You see these, just push it upwards and it will come off easily, just like here. But first you have to disengage these retaining pins for it to move upwards, and disengage the gear meshing. So yeah, it's quite a handy design. uh, yeah. So yep, that's the design. Thank you. Okay, so another thing about the discontinuity in the shaft and uh, the thrust bearing, let's see. So you see, we have, this is the shaft coming from the motor NEMA 23. So I'm giving this example because on each motor, wherever I have added the thrust bearing, the scenario is same. I'll show you that as well. So this is the shaft coming, then this region is the plastic region of the cover, then comes the thrust bearing, and then all the plastic again of the cover. So there is no effect of thrust bearing with the shaft. There's no contact in between them. The shaft functions as it will function, and thrust bearing will function to eliminate the friction in between them. So you can see here that the shaft is rotating. It will rotate, and the thrust bearing will just function to eliminate the uh, friction. If I show you from this side, you will see that I'll have to, yeah, that's the shaft. It's into this length, and the thrust bearing is only helping in eliminate the friction over here. So coming towards this region, the same scenario. Shaft works as it is, and the thrust bearing will just eliminate the friction. No contact of thrust bearing in the shaft. And likewise over here. So yeah, that's the answer. Update on Guardian Band Design 2. Uh, First of all, let's see the insides of it. We have the PCB here, right? And this is the charging port, and this is also used for the coding. Next we have this is the heartbeat sensor over here, uh, and this must be close to the uh, skin. So approximately it is 1.5 or 2 mm away from the skin. I have a protective glass lens over here for the contact. Okay, we also have a dust sensor here. We can see that E1 and E2, these are its pins. We'll just need two metal strips over here that will conduct the electricity through the sweat. The more the sweat, the more conductivity, and that's how we will know that we have sweat over here. So this is the transformer that will be used for the taser effect, and then we have the 3.7 volt battery here. Coming towards the upper section, now we have the wrist band. This is the locking mechanism buckle of the band. Let me show you how it works. So the strategy is the same. This buckle stays right here. If we want to tighten it like this, over here we will tighten it up. Yeah, I'll pull this like this, so this diagonal or tapered face will lift upwards with this straight edge. You see, if I bring it here, this edge hits this, and this will lift as this hits until it is above. Then this will move forward and it will fall back when the next dip comes, right? And now let's suppose if I want to release or loosen the buckle, the whole strap, I'll push this backwards, but I will not be able to loosen it because this straight face hits against this straight face of the strap, so it won't allow to loosen this up until it's met with shear or extreme force, right? So that's the update till now. On top of that, I'll be adding a magnetic plate here that will be electromagnet. So once that will be energized, this magnetic section will be pulled upwards by the electromagnetic forces, and this will be our let's say go no go situation or release and restraint situation. Once the forces attract, the two metal plates attract, this will be our sign to release the strap to loosen it up. And yeah, that's how we will be going doing, and the rest is that I'll be adding a cover and maybe lowering this profile a bit. So yeah, that's the design. So let's do the dimensions on this. The total dimensions are, okay, we are having this in inches. Let me do in mm. Yeah, 44 millimeters lengthwise, and it's about 37 millimeters in the width, and height, I'm guessing it's 30 centimeter. Yeah, 30 mm. So yeah, that's quite a compact size. I've seen watches with a 40 by 50 mm face. Good. So this is the update on the new version of Guardian Band. First of all, let's see its outer sides. This is the rubber band wrist strap. We have some sensors here. This here is the heart rate sensor, and these two electrodes or terminals are for the sweat sensor, and these two terminals are for the taser action. We have micro USB-C type for the charger. This acts as a charger, and the coding jack. Yeah. So coming towards the inside of this band, we have a transformer. Then this is the entire PCB. This here is the battery, and you see that I've sectioned up the entire structure into three places or portions, you may say. First one is for the PCB, then battery, and then the mechanism of the band. This here is the transformer that took up the most of the space. These are the aligners for the screw. This is the single screw that will screw up the entire uh, mechanism. Yeah. So coming towards the mechanism, let's open this up lid. The phenomena is the same as the previous design. This is a magnetic plate, and this buckle has a magnetic face. This one is the magnetic face. So when energy is provided to this magnetic plate, it acts as a electromagnet, and it will generate electromagnetic forces which will pull this magnetic face upwards, and these two faces will come in contact. When these two faces come in contact, so this buckle has been raised up and we have a free band. The strap is free now, it can be loosened up. So that was the electronic part of this. Let's move towards the mechanical structure of how we can tighten up this strap. You can see that the buckle has a tapered face, and so does the strap. As the tapered face of the strap comes in contact with the tapered face of the buckle rises up until the strap is completely slipped out of this buckle, and then with the action of gravity the buckle will fall down again when the next ridge comes. And since this has a flat end, flat face, and this has a flat face, they both come in contact and we cannot loosen up the strap again. We can tighten it without the electrical signal, but we cannot loosen it mechanically. So yeah, that's the entire phenomena of this band. uh, yeah, so this is the update on your issue. So I've added a locking mechanism here. Once you've inserted the pin into the jack, then you will rotate it 90 degrees or a bit more here. So this um, will hold in place the wires of the pin, and it won't come off unless the wires are uh, again brought back up in any case. So yeah, this slot was necessary so that the jack can be inserted into the female one over here, and then this part here is for the lock. Twist the wires downwards and it will get locked. Thank you. Good. So this is the update on the new version of Guardian Band. First of all, let's see its outer sides. This is the rubber band wrist strap. We have some sensors here. This here is the heart rate sensor, and these two electrodes or terminals are for the sweat sensor, and these two terminals are for the taser action. We have micro USB-C type for the charger. This acts as the charger, and the coding jack. Yeah. So coming towards the inside of this band, we have a transformer. Then this is the entire PCB. Uh, this here is the battery, and you see that I've sectioned up the entire structure into three places or portions, you may say. First one is for the PCB, then battery, and then the mechanism of the band. This here is the transformer that took up the most of the space. These are the aligners for the screw. This is the single screw that will screw up the entire mechanism. Yeah. So coming towards the mechanism, let's open this up lid. The phenomena is the same as the previous design. This is a magnetic plate, and this buckle has a magnetic face. This one is the magnetic face. So when energy is provided to this magnetic plate, it acts as a electromagnet, and it will generate electromagnetic forces which will pull this magnetic face upwards, and these two faces will come in contact. When these two faces come in contact, so this buckle has been raised up and we have a free band. The strap is free now, it can be loosened up. So that was the electronic part of this. Let's move towards the mechanical structure of how we can tighten up this strap. You can see that the buckle has a tapered face, and so does the strap. As the tapered face of the strap comes in contact with the tapered face of the buckle rises up until the strap is completely slipped out of this buckle. And then, with the action of gravity, the buckle will fall down again when the next ridge comes. And since this has a flat end, flat face, and this has a flat face, they both come in contact and we cannot loosen up the strap again. We can tighten it without the electrical signal, but we cannot loosen it mechanically. So yeah, that's the entire phenomena of this band. Uh, yeah. Okay, so this is the update on the JogLynch project. This is the third update on the design. We had a problem that the jack that was previously here came loose when the person slept. So I've come to the solution. I'll show you. So I have inserted the jack inside the enclosure, and this will remain permanently attached with the PCB. The relief area for the jack and the wall here is about 1.5 mm. I'll show you that. 1.5 mm, right? So even if the user tries to take it out while the PCB is mounted, so he won't be able to take it off. About the attachment of this wires into the enclosure box, the wires need to be placed in this slot while the box is being 3D printed. So that's the only way we will be able to fix this wire these wires into the box without giving it through opening from here, which won't be a practical approach. So I've seen people do this, put wires into the 3D box as it is being printed, and they remain there for whatever the life is of the box. So yeah, that's the thing. Okay, so this is the update on the JogLynch project. This is the third update on the design. We had a problem that the jack that was previously here came loose when the person slept. So I've come to the solution. I'll show you. So I have inserted the jack inside the enclosure, and this will remain permanently attached with the PCB. The relief area for the jack and the wall here is about 1.5 mm. I'll show you that. 1.5 mm, right? So even if the user tries to take it out while the PCB is mounted, so he won't be able to take it off. About the attachment of this wires into the enclosure box, the wires need to be placed in this slot while the box is being 3D printed. So that's the only way we will be able to fix this wire these wires into the box without giving it through opening from here, which won't be a practical approach. So I've seen people do this, put wires into the 3D box as it is being printed, and they remain there for whatever the life is of the box. So yeah, That's the thing. So this is the update on clench detection EMG project. We had an issue that the jack that was previously over here came loose during the night when the user slept. So for that, I have come with an solution. Uh, so this is the jack I have inserted into the enclosure. So once we are assembling the PCB, once the PCB is placed, the jack will be inserted into the PCB, and through these, through this channel, the wires will be placed horizontally over here. They will be inserted vertically, and then they will be placed horizontally into this slot, and then the wires will be clamped or screwed with a plate above these wires into these two holes. So that's the mechanism that's being used to restrain this jack from coming out of this box. That's a solution. So yeah, the box has been increased in length 15 mm from previously, now it's 105 mm. I'll show you the dimensions. uh, yeah, from this phase to this phase we have a, yeah, so the dimension is 105 mm. So this is the electronics demo of the Prayer project, Prayer bracelet. This is the PCB. We have the ESP here, and then C-type charger. We have the soldering pads of OLED display over here, and battery, touch sensor, and some buttons. Okay, so the configuration is that this is our 3.7 volt battery. It's around, let's do the dimensions of the battery first. It's about, give me a second, it's in inches, millimeters. Okay, so the length is 35 mm, width is about 9 mm, and the height is about, let's say, 4 mm. Yeah, so that's the compact battery size. We have the OLED display over here. These are the four terminals which will be soldered with copper wires to the pins here, and it's not in the air. We will have a padding beneath this OLED display to make it a compact, and then we'll give it a compact enclosure and produce a final look of the bracelet. So this is just an electronics basic demo of how we will be placing the electronics into the enclosure of the praying bracelet. So yeah. Hey, hope you're doing good. So this is the update on the vending machine robot version. You can see that I have a robot here and an inflating table. We have some racks here. The compartments sum up to be a total of 100. We have helium tanks over here as well into the whole enclosure of the vending machine. Okay, now let's talk about the approach that I'm using. We have a suction plate over here on the end effector of the robotic arm, and so we likewise we have a suction plate onto the inflating table, a raised platform that will be used as a clamp. The suction will be the clamping force, and here we have a nozzle. This is a moving part. This nozzle will be used to inflate the balloon. So let's see how this works. uh, for a better view, let me open it to a section view. so that it's more clearly visible. Yeah. So let's actuate the robotic arm towards the balloon we are trying to inflate. Let's say the user said, I want uh, the column, let's say XYZ balloon, and we have to inflate this one. So let's move the robotic arm there. This gantry will stay straight. The robotic arm will rotate to its position where we want to rotate it. Pick up the balloon from where. So actuate this forward. Robotic arm, little bit twist. Yes. Move down. This must be raised a bit. A bit, yes. So if we see it correctly, we're into this box. So let's make it parallel to this box. Uh, yeah, like that. A bit upwards. Good. Uh, Now let's pick up the balloon. Let me just grab the balloon and then we'll come back up. So now you can see that the suction cup has picked up the balloon and the suction plate, and now it will place it onto this rack. Uh, let's move this back, float a bit. Let's move it to the vertical position again, and we will rotate it like so, back a bit, move up, and then this arm will, let me fix it, this arm will place the balloon over here. Yeah, like so the robotic arm has placed this balloon onto this plate. So this suction was stopped from here when the balloon was placed onto this raised platform. Now this suction here is acting as a clamping force onto the balloon. Now this the robotic arm will move actuate back, and it will go to its mean position. Now here the nozzle will come and it will inflate the balloon from this neck. Like I said earlier, we'll have a uh, arm that will protrude from below the table, come up, and then it will skewer the neck horizontally so that it doesn't move from its place. Once the nozzle has inserted into the balloon and inflated the balloon, it will go back and the balloon will be floated up, collected into a collection chamber that's up here, that will be up here in this region, top center, and then we'll have the all tie part and attaching the weight to the bunch of balloons. And then over here onto the left top we'll have a dispatching chamber. Yeah, so that's the approach. Thank you. अस्सलाम वालेकुम सर। अच्छा, तो ये जो कैमल प्रोजेक्ट है ना, उसके अंदर हमारे पास ये फ़ाइल है ये अभी, और इसके अंदर अभी टोटल हमारे पास 10 मोटर्स हैं, 4 और 6, 10 मोटर्स यहाँ हो गई। अब जो रिक्वायरमेंट बता रहे ना, वो कहता है कि हमारे पास चाहिए मूव यूजिंग लेग लोकोमोशन, नो व्हील्स। और जो हमारे पास अभी है ना, वो لیگز ہی ہیں, لیگز لوکوموشن ہے, مگر وہ کہنا چاہ رہے کہ یہ جو ویلز ہیں نا, ویل گیئر اس کو کہہ رہے ہیں ہم, تو شاید وہ کہہ رہے یہ اس طرح لوکوموشن نہیں ہونی چاہیے اس کی. اب آئی ہیو نو آئیڈیا کہ وہ کون سے ویلز کی بات کر رہے. ان ویلز کے علاوہ ہمارے پاس اور ویلز نہیں ہیں یہاں پہ. تو وٹ آئی پرسیوڈ از کہ جو گیئرز یہ والے ہیں نا وہ ان کو ہٹانا چاہ رہے ہیں. اچھا, یوز لیگ لوکوموشن مطلب کہ وہ جس طرح آپ کی لیگ کام کرتی ہے نا, کہ یہ بھی تو ویسے ہی کام کر رہے, یہاں سے جوائنٹس ہل رہے ہیں نا اس کے, تو اگر یہ نہیں کرنا تو اس نے جوائنٹس موو کرانے ہیں, وہ بھی اس نے ویسے ہی کرنا ہے. اور پھر اس کی جو دوسری ریکوائرمنٹ ہے 8 موٹرز ٹوٹل, تو مطلب وہ 4 جوائنٹس مانگ رہے. ایک دو چار ہپ جوائنٹس ہو گئے, 4 موٹریں آ گئیں, اور 4 جو ہے آپ کے نیچے نی جوائنٹس ہو گئے. 1 2 3 4 ہو جائیں گے یہاں پہ, مطلب یہاں پہ جو 3 لنکس لگے ہوئے ہیں وہ 2 ہو جائیں گے, مطلب سیم لیول پہ آئے گا یہ. اوکے, دین نیکسٹ ہی ٹاکس اباؤٹ از 4 legs total, 2 motors each will be made. 4 legs, 2 motors each will be made. Well, 2 motors on each leg. تو وہ یہ کہنا چاہ رہے ہیں. باقی تو ڈسکرپشن وہی ہے اس کی, پہلا اس کا رف کیٹ چاہیے, پھر دوسرا ڈیٹیل چاہیے. مسئلہ صرف یہ آ رہا کہ اس کی بریف جو ہے نا وہ تھوڑی سی لیس ڈیٹیلڈ ہے. مجھے تھوڑا سا اور اس کا چاہیے ہوگا کہ کیا وہ میکانزم چاہ رہے. نو ویلز اس نے کہا ہے. اب آئی ایم ناٹ شیور کہ وہ کیا چاہ رہے اس طرح. ہیلو, السلام علیکم. اچھا سر, یہ جو ڈرون پروجیکٹ ہے اس کے اندر جو کنیکٹرز ہم نے یوز کیے ہیں نا وہ انسٹرکشنز میں آئے تھے کہ ہمیں انسٹرکشنز میں جو کنیکٹرز چاہیے نا وہ یہ والا نہیں لنک, یہ تو انٹرنیٹ, یہ والے کنیکٹرز چاہیے تھے ہمیں. پاور ان پٹ اینڈ آؤٹ پٹ ہائی وولٹیج انٹر لاک لوپ, یہ والے کنیکٹرز ہمیں لگانے تھے. تو یہ میں نے ڈی جی کی یا ماؤزر سے اٹھائے تھے, تو یہ والے میں نے لگائے ہیں اس کے اوپر. اب ان کے اوپر آگے فردر کیا کام کرنا ہے وہ مجھے بتا دیں, اگر کنیکٹرز چینج کرنے ہیں یا پھر انہی کو تھوڑا سا فیزیبلٹی ان کی دیکھنی ہے تو مجھے گائیڈ کر دیجیے اس بارے میں. Hey, hope you're doing good. So this is the update on the drone project. In the design 2 where we had the 2 wings rotating in coaxial direction. So the update wanted was the connectors needed to be the same on the each side. So these are the HIVL connectors, interlock connectors. I've added the female ones on both sides of the body of the drone. So you can see that coming towards its motion. Let's see how this moves. So you see that the both wings are rotating in opposite direction, one's clockwise and the other's anti-clockwise, and the plane drone was moving upwards. So that's the update. Thank you. Hey, hope you're doing good. So this is the update on the initial draft of the 4 leg locomotion project. You can see that we have 4 legs and 8 links here, 4 on the front and 4 on the back. So we have a total number of 8 joints, 4 hip joints and 4 knee joints, and saying that we have 4 motors, 8 motors. So yeah, we have 8 motors over here, and we can see that its movement, the knee joint moves and the hip joint moves. and the feet is stationary as it is. Likewise, this, the back limbs are a bit larger or have a bit more length than those in the front, so the distance would be of 20 or 30 units. So this is the required, this is the draft of the requirements you provided. So yeah, thank you. अस्सलाम वालेकुम सर। अच्छा, ये मैंने सॉलिनॉइड वॉल्व जो है वो डिज़ाइन कर लिया है। तो इट्स G1/8, तो 1/8 इंचज़ का सुराख है वाला। तो अब इस हिसाब से जो है ना हमें अपनी फिटिंग्स वगैरह देखनी पड़ेंगी। बाकी तो यही है। ये इसके माउंटिंग होल्स हैं दो M4 के, और ये है इसका 1/8 इंचज़ का सुराख, और इफ इसका 0.1 mm है। You're doing good. So this is the update on the holster vending machine. In today's work, I added the exterior frame onto the machine, and this is the x-axis of the gantry that I'm making. This is a Cartesian 3-axis gantry, x, y, x, and then y, and then in the downwards direction, and that's going to be z. So how we are going to work, the gantry will have an end effector of a clamping vise, so that the two faces clamp a box, that's the crate over here, and that vise will bring it to the crate to this station. When this bag reaches this station, the clamp will release the crate into this bag, and then the bag will be dispatched to the next conveyor. When it reaches here on the station 2, the bag will be placed into the holster, and the holster will be simultaneously hanged above here, on top here, and it will be then dispatched in this area. So yeah, that's the update on the work today. Yeah, thank you. Hey, hope you're doing good. So this is the update on the staff project. we have a lower part, upper part, and a middle part of the staff. So coming inside of the staff, we see that we have a vibration motor, three cells stacked up together, and then we have a LED uh, disc. So you can see that the top part is screw insert into the middle part, and so is the bottom part. So that's the update for now. Into the proceedings of the design, I'll be adding buttons over here in the middle shaft, where the most likely the hand placements will be. I'll be adding two buttons, one for the uh, on on off of the motor, and the other one of the on of the uh, LED. And a globe is also due in the next uh, update. So yeah, that's for the that's for now. Thank you. Hope you like the design. Hey, hope you're doing good. So this is the update on the staff project. As you said, we have a globe, uh, and we have LEDs over here. This LED, I'll add the link in the bomb, and this globe attaches via screw to the upper part of the shaft. This is the upper part of the shaft. Let's see this. It has a through hole for the wires to pass through. Now coming back towards the middle shaft, we have quite a few things going on in here. First of all, we have a screw insert threading that to attach the upper part to the main body, and then we have a two buttons over here that are going to on and off the motor and the LEDs. Now coming towards the bottom, we have a vibration motor over here. This is the vibration motor, 3 to 6 volts DC, and then I'll add the link in the bomb as well. This is the motor, and this is its casing. This is a cotter pin that I've added to stop it from falling down. This is the cell casing, battery rechargeable cell. This is the one terminal, and the other terminal is here. You can either tack weld or meg weld. Tack weld is better. uh, Wires to this surface of the cell and bring wires here. These holes in the structure of the casing are for the wires to pass from below to upwards, and then you can add a connection to the wires over here as well for the charging. Okay, so again, a threaded feature for the lower part of the shaft to go inside. Then this shaft comes along. This also has hollow for the wires to pass, and then this end part here also is threaded for this is actually the housing for the module that we're going to use for charging the Leon cell, lithium ion cell. So yeah, that's the entire structure of the shaft. Hope you like the design. Thank you. Hey, hope you're doing good. So this is the update on the Holstrom vending machine. In today's work, I've re made the x-axis uh, of the Cartesian system. I had to expand it so that it could reach the corners here, station 1 and station 2 at the corners. uh, and then I designed the y-axis of this Cartesian system. You can see that this moves, and likewise we have the x-axis. uh, Next forward, we have the clamping vise that will be somewhat like this. That's the clamping vise. So these two will move inwards when we want to pick up the crate and place it into the bag. So yeah, that's the forward step.
to add a z axis on the Cartesian system and attach the vice clamp, sorry.
Hey, hope you're doing fine. So this is the update on the new design of the holster and the vest. So you see that the holster has a clip now, like so, which will be inserted into this pocket I've made into the front plate of the holster. So it will sit inside this inside this pocket, and the user will be wearing this vest. So we have buckles over here that will be used to reinforce the two straps together, and some buckles here that will be used for tightening or loosening the uh, holster straps. So yeah, that's the concept right now. Hey, hope you're doing good. So this is the configuration of the mechanical structure of the mining robot. So this is basically a hydraulic cylinder on which the system has been mounted. This hydraulic cylinder's head goes into the base plate of this and is secured by a pin through this hole. Now how this works is the actuator will move it forward, and now this will be aligned onto the drill hole, the pre-drilled hole. So to know that this whole cylinder needs to be mounted on one of the legs of the drilling machine rig. And now once that has been mounted, this stays in a place extended. So this means that the arm has been deployed now. So let's just fix it. Okay, now this is the spool of rope. A motor will be attached over here, and the rope will start uncoiling. Let's say we have a plane. Let's say this is our ground. If you can, let's say this is the ground level, and the probe will first touch the ground, calibrate itself, and then the device will go inside the hole into the depth. So okay, so this was the system. If we have added another feature in this one, that this whole arm rotates. But as you mentioned about the availability of 1224 volt DC and hydraulics at your place, we need to find a compatible motor that will be 24 volts DC and uh, up to your requirements. So actually, yeah. Now once we have measured the depth and the device has been done with its work, we can actually deploy the arm this way so that it's out of the range of drilling machine or the rig and does not interfere with the process of the rig. And when we want to just check the probe, check the depth and parameters as mentioned, this can be deployed in this manner. So yeah, that's the update till now. I hope you're doing good. So this is the update on the car simulator project. I've added the electronics inside the box. You can see that here is the PCB, and this is the power jack of for the PCB. These are the connectors for all the limit switches present inside the box. 6 connectors for 6 limit switches inside this box.
Yeah, that's and a switch for on off as well. You can see that no wire is coming out of this box as it is wirelessly controlled through this ESP module. Uh, Coming back towards the clutch box, we've added a LCD display and a speaker. I'll show you inside. This is the LCD display, we have the speaker, and this is the actual trigger of the this clutch, which will determine the biting point. Well, the sound will determine the biting point, and when the user presses this clutch, this will the button will be pressed by this lever, and this means that it will generate a signal, so we can control the uh, gear through here. The biting point will be generated through this signal when this limit switch is pulled. Okay, so we have electronics here as well, a Wi-Fi controlled ESP module, and then we have a power jack here as well. Also we have a power button placed over here. So yeah, that's the design now. Hope you like it. Thank you. Hey, hope you're doing good. So this is the update on the rig winding project robot. So let's suppose this hole is the exterior frame of the rig, and this is our robot mechanism, right? This is the hydraulic cylinder. Yeah, and this is the hub for a motor rotation joint over here, and this is the winch attached to a motorized winch, and this is the rope. A device having all the sensors will be attached over here. Let's suppose this is the hole that has been drilled into the ground by the machine. Now we want to first deploy the arm onto the hole. So the hydraulics actuator will push this forward. If it's not fixed, yeah, the hydraulic cylinder will push it forward, and you can see that the hole is aligned, the rope is aligned on the hole, so that the device is going inside this hole. Now this is the mechanism so far. uh, I've also added an extra feature of rotation that you may see over here. uh, let's say we've done with the uh, measuring of the hole depth and all, so we just want to take it out of the way. This is a motor hub. The motor inside will rotate this whole winch to a side, and we have the whole space open without any interference of this robot into the action of drilling rig operations. So yeah, that's the design right now. This design is actually made on to the requirements. As you said, we have hydraulics available and 24-volt DC available, so yeah, and this is also a easy to replace design. Yeah, hope you like the design. Thank you. Hey, so this is the take two on the design of the mining robot. So the addition I have done is that I've actually mounted this robot onto a railing mechanism, and same like the hydraulic I showed you in the previous video, the actuation is done on by the hydraulic, but the additional component here is this rail. So this helps to eliminate the vibrations and stabilize the system a bit more, as it has a greater surface area rather than a slender rod that extends without any support, without well, actually, the support area is a bit less and is greater in this design, but this will interfere in the rigging operations. So yeah, it was just another approach for the design. The working is same of the robot in either designs. So yeah.
अस्सलाम वालेकुम सर। अच्छा, तो आज के काम में जो है ना, ये प्रेशर चैम्बर बनाया था मैंने, और साथ ये छोटे दो चैम्बर्स बनाए हैं, बंदे बताया था। गेज लगाई है और साथ ये दो होजेस निकाले हैं। होल्डर लगाया अंदर, होल्डर, ये ईयर प्लग है और इसके साथ से दो पाइप्स निकल के आ रहे हैं, इन दो होजेस में जाएंगे और ये फिर आगे कनेक्टेड हैं छोटे चैम्बर्स के साथ। इन दोनों के अंदर हमने प्रेशर टेम्परेचर सेंसर मॉड्यूल रखा हुआ है और ये वायर्स आ रही हैं इस डब्बे से बाहर। ये डब्बा जो है ये हमारा लगना है इस तरफ वॉल्व के आगे। वॉल्व में ग्रैब कार्ड से वॉल्व जो है वो मैं डाउनलोड करने की कोशिश कर रहा हूँ। आज शायद मैंने ज़्यादा कुछ डाउनलोड कर लिया ग्रैब कार्ड से, तो मुझे एक्सेस नहीं दे रहा डाउनलोड करने की। तो बाकी तो यही है, अभी इतना काम हुआ है।
अच्छा सर, ये गार्डियन बैंड का जो है ना काम, इसके अंदर असल मसला क्या आ रहा है कि हमारे पास एक तो ये रेक्टेंगल शेप होने की वजह क्यों है, हमारे पास पीसीबी है वो रेक्टेंगुलर शेप में पड़ा है, ठीक है। दूसरी बार हमारे पास ये बैटरी आ रही है यहाँ पे, ये हमारे पास है 3.7 वोल्ट की बैटरी है लिपो। और फिर यहाँ पे जो ट्रांसफार्मर पड़ा है ना बड़ा, इसकी वजह से हमने ये रेक्टेंगल शेप रखी थी, तो ऑब्वियसली डिज़ाइन चेंज करना पड़ा था हमें इन सारी कंपोनेंट्स की वजह से। फिर अगर हमने इसको सर्कल में करना है ना, तो वो इतना बड़ा सर्कल हो जाएगा और वो फिर हमारे लिए फिजिबल नहीं रहता ना। वो बाजू पे पहनेंगे तो वो इतना बड़ा लगेगा, ऐसे लगता है जैसे दीवार वाली घड़ी उतार के बाजू पे पहन ली, ये वो वाली चीज़ लगेगी। एनीवेज, मैंने डिज़ाइन करना है, मुझे जैसे इंस्ट्रक्शंस मिलेंगी मैं कर दूँगा, दैट्स ऑन द इंस्ट्रक्शंस। बाकी चीज़ें जो इस तरह आई थी मैंने उनके हिसाब से फिजिबिलिटी देख के उनका फिर मैंने एक रेक्टेंगल देखा था। नहीं तो पहले तो ऑब्वियसली गोल सर्कुलर शेप डिज़ाइन था, तब हमारे पास पीसीबी नहीं था जब मैंने डिज़ाइन बनाया था तब। तो ये इसके अंदर कर सकते हैं, फिर हमें इसके अंदर इलेक्ट्रॉनिक सारी चेंज करनी पड़ेगी अगर डिज़ाइन चेंज करते हैं, तो वो फिर मतलब कि कह लें एक तरह से सारा नया प्रोजेक्ट शुरू हो गया। Hey, hope you're doing good. So this is the update on the staff project. This is the dome and the LEDs inside. The dome is fixed to the main shaft via the threading. Okay, so let's get inside the shaft itself. This is the LED panel. Let's remove this for now. This is the upper part that is inserted into the shaft. It's split into two halves. First of all, let's see this. So we have metal contacts over here as well and onto the main shaft as well. So these are a pair. This one is for the main shaft, this one is for the upper part. You see that this part has been sliced in half and is secured by these grub screws, and this part is the aligner part that sits into the alignment part of the shaft. So this is the springing mechanism, spring lock of the this part. It has on both sides so that with the gravity this part does not slides off the main shaft. Okay, now let's bring back the shaft. This hole is for inserting a pin. If you want to remove the part inside, insert it here, insert a pin into it, push the pin, and this part will slide out. It will release the lock and it will actually slide out. So we'll have to insert the pin from both sides to take it out. this is the Carter pin, a support for the motor. This is the vibration motor sitting inside the main shaft. I was talking about these aligners. So this is the um, motor casing, we'll say, or motor mount. It's sitting on this Carter pin so that it does not falls down with the gravity. 4 holes have been given into the motor mount for excess of wires, and on the last of this guide here sits the battery rechargeable cell. This is a thread locked of the cell, so just insert the cell into this and lock it from behind or top. So these two holes are again for the wires to pass through holes, a hole here as well for the soldering or wire access. Now coming down here, we have the same mechanism that we had on top. These are the secure lock pins that when you've inserted the lower part into the main shaft, it does not falls down due to the gravity. Contact pins as shown. So yeah, these are the contact pins. I've just misaligned these. I'll get to them and make them straight. Okay, so inside we have two buttons here. You see we have two buttons, and again this part has also been split into two and is secured by grub screws. And down below we have the charging module. This is a threaded part. We have threads over here, and the charging module will sit here, means that the C type will be here at the very bottom of the shaft. So yeah, that's the design for now. I'll bring back the LED and the dome. Hope you like the design. Thank you. Hey, hope you're doing good. So this is the update on the alarm system casing. You've seen that I've centered the LED panel, and also I've added a sheet sorry, the translucent plastic sheet in front of this yellow panel. The C-type port is here, and the knob vents for the audio system. Let's see what's inside the actual enclosure. Over here we have the battery casing and 3 cells in it, and this is the box to actually hold the potentiometer in its place, so it's screwed up with the wall. So yeah, that's the arrangement of the enclosure. Hope you like the design. Thank you. अस्सलाम वालेकुम सर। अच्छा, गार्डियन बैंड पे अपडेट ये है कि बैटरी हमें मिल गई है सही साइज़ की। बैटरी लगा दी है, 5 mm इसकी थिकनेस है बैटरी की। अब जो टोटल हाइट में लेके चल रहा था ना, वो गार्डियन बैंड की वो थी हमारे पास 20, नॉर्मल डिस्टेंस 20 आ गया। अब रिमेनिंग जो बची हुई है ना मेरे पास, वो आएगी 6.21। अब बैटरी के ऊपर अमूमन तो मैं सेपरेटर डालता हूँ कि बैटरी और ऊपर वाले जो सारा है उसके अंदर सेपरेशन आ जाए। अब नहीं, मैं बैटरी यहाँ पे रख के इसके ऊपर ही मैं सॉलिनॉइड रखूँगा और लॉकिंग मैकेनिज़्म सारा इसी के ऊपर लेके चलूँगा। तो ये है। और दूसरी बात कि 6 mm जो स्पेस बची है ना, वो कम है। मुझे ऊपर अप्रॉक्सीमेटली 6 या 14 और डालनी पड़ेगी टोटल करने के लिए। 2 mm मैं थिकनेस लेके चल रहा हूँ वॉल की। 3D प्रिंटिंग के लिए जो है ना, वो 2 mm चाहिए होती है हमें। ये बात होगी। और दूसरा स्ट्रैप्स तो फिर इसी तरह साइड से निकलेंगे, एक इस तरफ से और एक उस तरफ से। और स्ट्रैप जो होगा ना, जो इनलेट पे आएगा वो हाइटेड होगा। यहाँ वाला इधर से यहाँ से आएगा, बिल्कुल बेस लेवल से निकलेगा। तो अगर कहते हैं तो मैं इस वाले को भी ऊपर हाइटेड कर देता हूँ, दोनों सेम लेवल पे हो जाएं तो बहुत ज़्यादा बेहतर लगेगा। बस ये है कि आपकी घड़ी ये वाली जो वो आपकी रिस्ट के साथ लगी होगी और बैंड्स जो हैं वो थोड़े हाइट से निकल के आ रहे होंगे। खैर इतना बुरा भी नहीं लगेगा। बाकी ये डिज़ाइन चल रहा है अभी। Hey, hope you're doing good. So this was the part that I forgot to add in the bomb. This is a 1 by 8 to 1 by 4, 1 by 8 male to 1 by 4 female regulator that I missed in the bomb. So once you attach this to the solenoid and the same part will attach over here with the bent 1 by 8 female to the 1 by 8 male of this regulator. So your assembly will align. There's no exclusion in the parts that are given to you in the BOM, but this was the part that I forgot to add. And yeah, if you put this, so everything will align. This is the location where you have to add the part. Hey, hope you're doing good. So this is the update on the Guardian band. You can see that. Uh, let me just show you. Yeah, these are on. Okay, so this is the Guardian band new design. Let's bring back the lines. So the strap will come out from this hole. Now this is the C type. Below we have a activation button port, heart sensor, and then we have the electrodes for taser and for sweat sensor. Moving into the enclosure. Yeah, moving into the enclosure, you see that we have a solenoid valve here, solenoid actuator actually, and we have a locking mechanism. So first of all, the concern is that this lock will move horizontally like this, but no, this is a integral shaft of this lock, and it will be secured in the center via these holes. Okay, now how this system actually works, for that I'll be showing you by this view, and let's just get rid of this for now and make you see visible the internal structure. Now you see that the band has cutouts like this, tapered, and this lock is also has tapered edge both ways. The solenoid moves to and fro. Now our loop is going from here to here, so that this is the loosening side, and if we pull this way, it tightens. Let's just say that the this is our home position, right? Now if we want to loosen this, we will pull it backwards. Now you see that this edge and this edge will intercept each other, and when we're pulling this back, this will fall down because these are opposite tapered edges. So this will slide down. But then if we want to open this lock, we want to open this by the action of this electrical signal through the solenoid. This will move forward, and then this edge will hit this slanting surface, which will start to move below. As it moves forward, this whole face moves below, and you see that this lock is free. Now we can pull it back. So yeah, that's the mechanism. This will auto close under the action of gravity because this side is a bit heavier than the other one. So this will always remain in the home position. Now rest Rest of the band is let's remove this for now, and this as well, the solenoid and its head. Now we have a battery inside, and under the battery we have the PCB. This is the guides of the strap that will make them come to its place. So yeah, that's the design right now. Hope you like it. Hey, hope you're doing good. So this is the update on the pressure chamber. Let me just walk you through the process. So first of all, this is the pipe for the input. It will be connected to the ITV to maintain the pressure. Now let's come inside the main box. You see that our setup for testing the pressure against the outputs, against the ends of the earplug, are is placed inside the main box. Now this is a small chamber just like the big one. Now this will tell us about the pressure inside the main box. So we have a sensor placed inside the main box. Likewise, we also have a manual gauge here that will tell us the pressure, but yeah, that's manual, so it can readings can differ. Okay, now coming back towards the earplug, you see that we have two tubes coming out of both ends of the earplug. They'll be checking the leakage and pressure difference across the earplug. Now, if we have a leakage, so the pressure of the two boxes will be same. Uh, the main one and the small one. This also has a uh, pressure sensor inside. So if there's a leakage, the pressure inside this main box and the small one will be same. But if there is no leakage and the earplug is alright, so we'll have a difference in the pressure of this box and this box, which will tell that the pressure is being which will tell that the earplug is not a faulty piece, it's a good one. And now we have also attached a pneumatic valve here, MEMS based pneumatic valve. Okay, this will just release the pressure in the atmosphere when required. So yeah, that's the setup for now. Hope you like the design. Thank you. I hope you're doing good. So this is the update on the cubes single unit for car blemish, and these are the wipes. Uh, you see that this upper one is the softer wipe and the inner one is the aggressive wipe. Mechanically fit, they are friction fit. onto the cube, the tolerance are very tight, so that they are friction fit onto the cube. Let me just show you how we can actually remove them. So the upper one, software pipe, slides off this way, and the other one slides off this way, and we relay single unit cube. In real life, this would be flexible fabric, so they will wrap around quite snug easily and will be friction fit onto this uh, cube. I'm playing with rigid structures right now, so you will see these sharp corners, but in real life you won't see sharp corners because it will be fabric and it will wrap around quite smoothly. So yeah, this is the design right now. Hope you like it. Hey, hope you're doing good. So this is the update on the card reader. This is the card, and this is the slit through which we're going to insert the card. We have a speaker here, and we have three LEDs, uh, which will indicate processing correct and incorrect values. So once we insert the card in this slit like this, so the internal circuitry will do the rest of the work. So this is the mock design of the card reader box, and these are the LEDs that will be indicating. This is the speaker here through which we can actually engage with the box. So yeah, that's the design for now. Hey, hope you're doing good. So this is the update on the Guardian Band project. So I finally found a solution that is good enough for our case. So let's see the first looks of the band. This is the loop, and this is the C-type charging port, and we have the heart sensor in the middle, trigger button, and these are electrodes for shock and humidity sensor. Now if we move towards inside the band or the face, we have, this is the PCB, this is the battery, this is the channel that will guide this band in between the battery and the solenoid, this lock, and this is the exit of the strap, and that's how the loop is going to be completed. Now let's talk about the mechanism. And obviously this is the lid, this will be press fit. Let's remove this for now as well. Okay, so you see that this is the strap and it's moving both ways. This is the solenoid. This is the solenoid which moves to and fro, and this is the buckle. So let's say we have to loosen the strap without the actuation of the solenoid. So we want to lose it, we'll pull this back. You see these two faces interact and this will move down. This moves down, so we are not able to lose the strap without the help of solenoid. Now if we want to lose the strap, but with the help of solenoid, now this will move back and this will start, these two faces will interact and this will push this downwards. The buckle will release the strap and now the strap is free to move backwards, which will lose the strap. And if we want to tighten the strap without the actuation, without the action of the solenoid, we'll just pull this forward. These two slanting faces will intercept each other. This will start moving upwards till it's out of the band, and then it will fall back down just like this, because this side is a bit heavier than the other one. With the action of gravity, this will fall down. So yeah, that's the mechanism of the band. The upgrade we did was we added a chute here, or a path, guiding path of the strap, which will guide it to the place where it has to slide. So yeah, that's the Guardian band. Let me give you a final visual of it. Yeah, hope you like the design. Thank you.